I supposed to... Aha. Ingress. That's right, we're going to be covering ingresses today, and we're also going to be covering load balancer services. The reason we're doing both of them today is because we're going to be setting up an ingress controller, and that requires a load balancer service. So we're going to need to cover what they do, what they are, and how they work. So I could talk about it more now, or we could just get straight into it. Let's do that. We'll be taking a look at the load balancer service type first, and then we're going to go ahead and take a look at the ingress. So there's quite a bit to take in here, and I'm going to try and be as clear as I can, but there's going to be a couple of little caveats as we move through this because we're working on essentially what is equivalent to bare metal nodes rather than working in the cloud. So there's going to be a few little differences, but I'll try and be clear. So you may remember a few videos back, maybe about 8 videos ago-ish, I was talking about services, and I said this about the load balancer service. If I deploy a load balancer service, a node port still gets created, a cluster IP still gets created, but it then also starts interacting with your cloud. If you're in Amazon or Google or OpenStack or Azure or whatever it might be, it starts interacting with that cloud layer. Give me a load balancer in the cloud, automatically configure it to route through to the node ports on these IPs. And that is where we will be going soon. And we're here now. This is where we are. We're going to be talking about them now. All that cloud stuff I mentioned, that's basically something called the Cloud Controller Manager, and that allows us to interact with the API of the cloud we are using. So let's just bring up some docs a second. Here we go. I'll link all this below, as I always do. But this basically will show you the layout of it. So you've got things like the Kube Controller Manager, the Kube API Server, the Kube Scheduler and Kube Proxy, things like that. All of it sits within components of Kubernetes. They are all components of Kubernetes and they all interact with one another to make Kubernetes work. The Cloud Controller Manager interacts with the Cloud Provider API. So for example, when you create a load balancer service type, instead of something happening on the cluster, it does. You still get the cluster IP type and the node port type, as I said in that previous video, but you also get something in the cloud, which is a load balancer. So it will go to the cloud, it will create a load balancer, it will create target groups or node pools, whatever you want to call it, that contain the nodes of your cluster, and those target ports of those nodes will be the node ports that are created as part of the service. So that allows an external IP to be attached to the load balancer. People can access that external IP, it hits the load balancer, and then it gets routed to one of the nodes within the node pool or target groups, depending on what you want to call it, depending on what cloud provider you use. If you ever used HA Proxy, then this might be familiar to you. It's same sort of thing, it's just load balancing in the same way HA Proxy does. If you ever use a load balancer of any kind, it's that sort of thing. So that's basically what the Cloud Controller Manager does, on top of other things. You can do other stuff via it as well, but that's just one of the features of it. So yeah, that's the Cloud Controller Manager. It interacts with the Cloud API. So how does that affect us? We don't have a cloud, we don't have an API, we have nothing. Well, that's where Kube VIP comes in. Now, if you remember right at the start when we set all this up, we used something called Kube VIP or Kube VIP, and that allowed us to create a sort of virtual load balancer across our control plane nodes, which meant we only had to hit one IP, and hitting the IP would hit any of the control plane nodes. The same thing's going to happen, but for our services. So if I jump over to the docs for that, we can see here we've got this Kubernetes load balancer service right here, and over here this says, yeah, we can use the type of load balancer. Great. We've got a watcher here that looks for that particular type, and we will configure an IP for it if we find it. But for that to work, we need the Cloud Controller Manager for Kube VIP, or the Kube VIP Cloud Controller. Again, it's just a Cloud Controller Manager. It's not coupled to anything other than the Kubernetes APIs, it says here, and there is no cloud to deal with. So all it's going to do is create a virtual IP, a floating IP that will hit all of our nodes, essentially. So what we need to do is apply this particular YAML file here, nice and easy. So we'll go ahead and just deploy that. Do kubectl, get pod, namespace kube system, and we should see it. There you go, it's up and running already. So what we're going to do next is set up a load balancer service type. So I'll jump over to my Kubernetes series here, and we'll take a look at the database. Database and web are copies like for like from the Affinity video that I did. And the only thing I'm going to change in here is node port, and I'm going to change that to load balancer. That's it. We'll do kubectl, apply F21, ingress, and then database. But before I apply that, the question is now, where is KubeVip getting the IP from? Let's go and take a look again, because I feel like there's going to be a little bit more we need to do. Oh, look at that. There is. Create a global CIDR or IP range. Yes, we need to do this because it doesn't know what IPs to use. In the same way that when we set it up originally, we gave it an IP and said, this is going to be our floating IP for the control plane nodes. We're also now going to give it a bunch of IPs to use for handling services. Let's go and take a look at this. We've got two options. We can create a CIDR or we can create a range. Now, if you want to create a CIDR, go ahead. If you want to create a range, go ahead. Because we've already deployed it, we have this config map. There's nothing in it, but it does exist. So you won't need to create it. You'll need to edit it instead. So I'm going to go ahead and grab that. We will paste that in. We will edit it and we will create a new field in here called data. And then in here, we will put a CIDR global or range global. Your choice, pick which one you want. I'm going to use CIDR : and then we need a range. So I'm going to use 192.168.0.220/28, I believe. I'm not going to use 220 anyway, I'm going to use 240, and that should give me from 241 to 254 if I've calculated that correctly. And yeah, that should do it. So I'm going to write that out. That means that any of those IPs will be available. Again, if you want to use a range, you can use a range instead. That's fine. This here is equivalent to this here. That's what it is. So that's everything we need. We've got a bunch of IPs to use. We've got the Cloud Controller Manager deployed. If we go ahead and just deploy the service now, we should see it just come up as a service with a load balancer IP. So I'm going to do kubectl get svc namespace learning, and I'm going to watch that, and then we'll go ahead and apply that, jump back over, and straight away, there you go. That's come up. Now, it wouldn't be this fast in reality on a cloud because it'd have to go off and create the load balancer itself and then attach an IP to it and then feed all that back, and this would get populated. But in our setup, it's really quick because we already have a range in a config map. So that's it. We now have an IP we can hit. What's the benefit of this, you might ask? Well, in previous videos with the services, I've had to hit this node port IP. So if I just grab that, because this will have changed since the last time I did it, and go to this MariaDB setup here, I'll paste that new IP in. We'll click test connection, and there it is. It succeeded. That's great. But this here, this is one of the many node IPs. What if that node goes down? I can't hit that IP anymore. That's it. It's gone. So this is where load balancers come in. They give me a single IP to hit. So I can just use this now, and no matter which node goes down, it will still work. And the other benefit is I don't need to use node ports anymore because I've also got this port here exposed in the load balancer level. So that means I can use 3306. And now if I go and test this, there we go. We've got a connection. Now I'm using a load balancer IP and I'm using a actual port of the service rather than a node port. And it's a lot easier to share that. If I tell someone to use the SQL port, they should know or be able to find out that 3306 is MariaDB's default port. That's the good thing about this. And on top, like I say, if any of the node goes down, as long as it's spread across multiple nodes, I can still hit that database. So thumbs up all around. And that's it. That's a load balancer service. That's basically it. And this is useful because it also comes in useful when it comes to setting up an Ingress controller in some cases. So what's an Ingress controller? Let's talk about Ingresses first. So I'm going to jump over to this Ingress page here. We don't need this anymore. That can be closed off. We don't need this anymore. That can be closed off, both of which will be linked into the description. This here is an Ingress resource. I'm just going to scroll up a little bit though, because here it tells you what an Ingress is. So it exposes HTTP and HTTPS routes from outside, so in the world, to the cluster services within the cluster. That's pretty much it. That's what an Ingress is. An Ingress controller facilitates that. So without an Ingress controller, Ingresses don't work. If I try and deploy an Ingress right now, nothing will happen. You need an Ingress controller to manage that traffic, essentially. Now, there are mechanisms coming out in quotes soon. I think it's the Gateway API or API Gateway, I forget which way round it is, that will pretty much replace Ingresses, and it will replace the need for an Ingress controller in the same way as what we need today. But what happens is the client will hit an endpoint, so maybe a domain like learning.example.com. That will be mapped in something like Cloudflare or whatever domain DNS system you use to an IP. That IP would be the load balancer's external IP. So you don't create a service type of load balancer. That gets created, in this case, we're going to use Nginx on behalf of Nginx Ingress Controller, for example. I will show you this as we go through anyway, so hopefully it will make more sense then. But essentially what happens is that domain will be mapped to an IP, the IP will be matched to a load balancer, the load balancer will contain, again, target groups, which will route through to your Ingress controller. The Ingress controller will then go, right, this is the domain you're looking for, and this particular path for that domain. I have an Ingress resource that will tell me to go to that service over there, and then the rest is history. Service then maps through to the pods. Okay, that's how an Ingress works. So what do we need? Well, an Ingress controller. We've just said that. There are a bunch of Ingress controllers. There's so many to choose from. I've used a few of these, but to be honest, I'm just going to go straight for the Ingress Nginx controller. For what it's worth, there is the Nginx Ingress controller and the Ingress Nginx controller. There are two. Make sure you get the right one. So the Nginx Ingress controller is the one provided by Nginx and contains some paid for features. The Ingress Nginx controller is the community provided one and is free. Doesn't have all the features of the other one, but it's pretty full of features that you don't need to worry about that. From this list, I've also used Traffic, I've used Istio as part of the service mesh, I've used the HA proxy one, I've used, what was the other one? Amazon's AKS, I think that is. Yeah, no, that's the Azure one. There's an Amazon one as well that's not listed here. Yeah, that's all the ones I've used. There's a bunch more. As you can see, I'm going to be testing the Cilium one soon-ish because we use Cilium at work and I use it on my own cluster, so it makes sense to have a look at the Ingress controller that they provide. That's it. There's a bunch here to choose from. We're going to stick with the Nginx Ingress controller though, so I'm not going to go to this link here because that is the Nginx one. What I'm actually going to do is go to the GitHub and go for the Ingress Nginx one, which as you can see is part of the Kubernetes project. So if I scroll down here, we've got this getting started document. If I jump over to that, then we have a bunch of options to get started. We're on bare metal, so we'll use that. And it says, if you want to just get going, apply this. Problem with this is it'll create a node port, not a load balancer, and then we'll just be in the same boat we were before. We need a load balancer service for this. So I'm actually just going to grab this and I will download this instead. So we'll just vim that. Yeah, that's not going to be very clever. Let me just get that actually. That was very silly of me. And then we'll vim deploy, and then in here we will have something somewhere with node port. There we go. So this is the Ingress Nginx controller and port 18443. So this is the service that listens on behalf of the Ingress controller, and this is a node port type. So I need this to be a load balancer. Like I say, this is just so I don't have to deal with node ports again. If I just set it up as a node port, I'm then still going to have to stick something in front to manage the traffic on behalf of this, which seems pointless when I've now got this load balancer feature. And in reality, in the cloud, you would have this as a load balancer service. That's the way it would work. So we'll right and quit that out. I'll then do kubectl, apply f deploy, and that will create a bunch of stuff for the Ingress Nginx. You can see it's got some role binding, service accounts, config map, service, deployments, jobs, Ingress classes, and a validation webhook configuration. This Ingress class we will be using shortly, so we'll just make a note of this. And this is called Nginx. We refer to this as part of the Ingress. I'll clarify that in just a second. And now I'm just going to do kubectl, get service, namespace, I think it's Ingress Nginx. Yeah, and you can see here it's created a load balancer service with this IP. And if I actually get the pods as well, this service maps through to this pod here. And this pod here is responsible for handling our traffic. So I'm going to do kubectl, logs, f, this, and Ingress Nginx. And we'll just take a look at these logs to see what happens as we apply some Ingress resources. So let's go ahead and do that then. So I'm going to jump over to Kubernetes series again, and we'll look at the web service first. So we've got the normal deployment, nothing fancy going on there. And then down here, I've also added a service for it, which is just a cluster IP type. It doesn't need to be anything else because the Ingress controller, because it's in cluster, can talk to cluster IPs. So I don't need it to be a node port. I don't need it to be a load balancer service. It just needs to be a cluster IP, which means this isn't exposed to the internet in any way whatsoever. And it's not exposed actually outside of the node in any way whatsoever. So we'll go ahead and apply that. And then we'll take a look at this Ingress file. So this is a new file, and we'll just quickly walk through this. So again, API version, kind, metadata should all be pretty straightforward now. You should be used to this sort of stuff, but just in case, it's part of the networking.ks.io, the API version. The kind is Ingress, metadata is name and namespace, and then we get into the spec. So Ingress class name, that's this Ingress class name that we made a note of up here. We've then got some rules. So we've got an HTTP rule. We'll get into TLS a little bit later when we start talking about things like external DNS and cert manager, but for this video we won't be touching on it. Don't worry though, we will cover it. But we're looking at HTTP rules. It's got paths, which contains a list of paths, which you can have as many as you need. So we could have something like API/v1 and API/v2. And these could go to like v2 and v1 services. And we've got this path type here, which is a prefix, which if I just jump back over to the docs, you'll see there's about 3 options, I believe, if I remember rightly. If I scroll down, path types, here we go. So you've got implementation specific, we've got the prefix, and then you've got matches, which matches it exactly with case sensitivity. So for example, if I said I wanted this to be exact, for example, then the path would have to be that. This in the browser wouldn't work. Okay, that's kind of where the difference is. So that's essentially what the prefix is there, the path type. And then we've got this backend. The backend is the service that we will route through to if this path is matched. Okay, so if someone just goes to /, so the host, so the domain /, then this will be hit. If they go to the domain /API/v1, this one will be hit. Same for here with v2. The backend is the service, like I say, this will just take us to the web service. So the name of web, it has to be in the same namespace. So this is in learning and this is in learning. The name is web, name is web. And then we've got this port here. We can use name or number. So one or the other, you don't need both. So name HTTP, you can see here, name HTTP or port 80. So they're the options there, okay? I'm gonna use the name because again, I could just have multiple. I could have HTTP, I could have SQL, I could have HTTPS or whatever it might be. So yeah, you can have multiple service ports in a single service and you can have multiple paths that map to each one of those ports if you wanted to. So that's the ingress path. So I'm just going to delete these two because I'm not going to need them anyway. And then finally, we've got this host. The host is just the domain. That's it. This is the domain we're going to be setting it up on. There's nothing more to it than that really. So let's go and set up that domain. So I'm going to grab that. In fact, I'm just going to grab the learning bit and I'm going to jump over to my Cloudflare account. Now I'm going to be blocking a lot of stuff out here, so I apologize in advance if it looks a bit weird, but I'll show you the bits you need to know. So I'm going to jump over here. I'm going to add a new record. It's going to be a CNAME record. It's going to be learning and @ and I'm going to click save. I'm just going to turn off proxy and that's that. So that's saved it. Now behind here, this little black box here is an IP address that's the A record. So this is my kind of root record and that has my external IP of my router at home. If you want to know how to get it, just type what's my IP into Google and it will either come up in a box down here, which again I'm blocking out, or it will come up under here. If you just click on this, it will show you your IP. That's the IP that's in here. The CNAME is just a alias. So learning.hudson-viles.uk will map through to this IP. That's what's happening here. But obviously in the host header, this domain will exist. So we can now route based on that domain. Now, in theory, all I need to do is do some port forwarding on my router and route the port 80 through to the IP address of the Nginx service. So if I jump back up, this IP, where's it gone? Where's it gone? Here. Okay, this 241 IP. That's in theory all I need to do. However, my router is a TP-Link router, and without publicly bad-mouthing TP-Link, they're really bad in that they've only given me an app to manage my router, and that app is not the best. So when I try and do port forwarding, I would expect to be able to just give it an IP and a port, maybe a protocol as well, and that's it. That's all it should need. For some reason, they also ask for a MAC address. I don't have a MAC address because this is a virtual IP. Now I could put the MAC address of one of my nodes in, but then it's always going to hit that one node. So thanks for that TP-Link. You've kind of screwed me over a bit there, but we're going to find a way around this. So what I'm going to do is I'm going to bring up my port forwarding setup now, and you'll see here I've got 192.168.0.3. This is actually my Intel NUC, which contains Nginx running as a reverse proxy, because why not? And essentially doing what the Nginx Ingress Controller does, it just runs as a reverse proxy. And it's basically going to take the traffic in, it will detect that it's something.hudson-viles.uk that isn't one of the domains that already exists on my NUC. For example, I have some other things that run on it. Those all have domains. They're all configured within the Nginx reverse proxy, ready to go. So if any of those domains are hit, they'll get routed correctly. Anything else will get routed through to this IP. And just to show you what I mean by that, I'm just going to quickly bring up the configuration for it. So you can see here, I have *hudson-viles.uk, and it just does anything on location /. So anything that comes in, basically forward on to the IP address of my Ingress service. That's basically it, the service IP. There is an extra hop here that I shouldn't have to do, but I'm having to because of TP-Link being really bad at setting things up for my router. I don't know why they didn't give me a browser. They gave me an app because for some reason everything has to be apps now. It's really frustrating for me because I've always set things up via the browser or directly, and now I'm stuck on a phone using an app. And if my phone breaks, I can't set up my router. Thanks TP-Link. Want to sponsor me? Yeah, right. Anyway, that's all I've done. So yeah, there's an extra hop here. It hits my router, goes through my Intel NUC, and then over straight away to the Ingress class. So nothing happens here. There's nothing fancy going on. This is just passing a few extra headers through to make sure that I get the X forwarded for the upgrading. Yeah, so I won't get into what these are right now, but just passing a few extra headers through. So that's what's going on there. Now looking back at the service here, everything should be working. So if I now go to learning learning.hudson-viles.uk. It should map through to the external IP of my router, hit my router, realize it's coming in on port 80 because of those rules, and then forward it through to my Ingress controller. Okay, via the internal NOC, but let's just ignore that bit for now. It should forward it through to my Ingress controller on this IP. Once it hits the Ingress controller will take the header, the domain, it will check the path, and then it will forward it to the correct service based on this Ingress resource that we are about to deploy. So let's go ahead and deploy this, and we will see in the Ingress pod here that it will reconfigure itself. So I'll just press enter a few times so we get a bit of a cat. So we'll do that, and we'll see straight away it's gone, yeah, okay, you've got an Ingress resource being added on. Here's the name of it. It's namespace learning. It's called web. It's using the Ingress class. It's found the correct one, which is Nginx. And then basically it reloads Nginx in the background, and it's ready to start accepting traffic. So I'm going to press enter a few more times, and I'm going to go ahead from here and just do curl http :/learning.hudson-viles.uk. And there we go. We can see we've got the Nginx set up here. Brilliant. That means it works. So we've hit that domain. That's not configured anywhere in my home network. That's only configured in my Cloudflare account. So it's hitting Cloudflare. That's getting routed through, like I say, to the external IP, to the router via my Intel NOC, to the Nginx service. Can I prove that that's the case? Yes. Back over to those logs. Here's that request that came in, and that's it. So that's working. So that in theory, I can just go ahead and jump into a browser and do the same. Now, I would do this in Chrome, but Chrome's been a bit funny with me in the past for this. Now, it should work, but I think I've got some weird cache going on somewhere that I've not cleared, and I'm going to use Firefox instead. So I'm going to jump in here and go straight to the domain. So learning.hudson-viles, and there it is. Welcome to Nginx. If you see in this page, blah, 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 blah. And if I jump back over to those logs on here, we can see that that request should have come in again. So let me just press enter a few times. We'll just refresh a few times, and there's those requests. That's basically it. That's working. You can see we came from Firefox here. That's all routing through from the web. It's not going through any local DNS or anything like that. I've got nothing like that set up. So that's all there is to show for now. Like I say, we will jump back in at some point and we will start looking at the TLS options. So to do TLS, we literally just jump down here. We do TLS. We set a secret name, which contains the secret for the SSL certificate, and we set a host again. So we can do that, and then we do hosts, and then we can do learning.hudson-viles.uk. This secret name is the secret that contains the certificate. We're not going to be doing that now because I'm not manually creating certificates for this. I'm going to show you how to do this automatically later down the line with Cert Manager. And also, we don't even need to interact with Cloudflare because there's something called external DNS that will do that for us too. But like I say, that's for a later video. So the last thing we're going to do is take a look at the Ingress resource itself. So to do that, we'll do kubectl get ing being short for Ingress, namespace learning, and we'll take a look at this. So we can see the name, we can see the class that we set, we can see the host that we set up, and then we've got this address field here. We've also got the port, but this address field is the one I want to look at because this isn't the address of the Nginx Ingress service, which is what it should be. Now, if you're running in the cloud, you'll get the correct address here. It'll be fed back from the Cloud Controller Manager and it will work. However, unfortunately, if you're using MetalLB or KubeVip, something like that on bare metal, then there's a few caveats to this working. We already know it works because we've tested it and it works fine. This is just the way it's being reported back to the Ingress resource itself. There are little workarounds on the Nginx website. If you take a look at it, you can do things like set external IPs and do things via the host network. I'm not going to be getting into that today because that's extra stuff that we don't really need to do, and the security considerations around that as well. So I'm not going to be doing that in this one. And to be honest, as long as you know that your IP is that one of the Kubernetes service, the Ingress service, sorry. So do kubectl get service namespace ingress Nginx, then this one's the IP that you need to set in your DNS record, basically, not this one here. This is just the node. And it's just, like I say, it's a little quirk. Don't worry too much about it. There might be another workaround I've not come across yet, but I'm yet to come across it. When we come to do external DNS, there is another annotation we'll need to set to make sure that it picks up the correct IP, as in the external IP, because we'll be setting CNAMEs up. Again, if you were running in the cloud, you would have proper Route 53 or Google's version of it, whatever it might be that you use, you'll have those features in place to be able to manage this, because you would have external IPs being generated as you need them. But we're not in the cloud, so we're having to do little workarounds here. So everything that you're going to learn from this point with regards to Ingress and external DNS, just kind of take with a pinch of salt because we're running in VMs locally. That's just something to consider. But that's basically it. And that's everything you need to know about load balancer services and ingresses for now. We do need to talk about securing our endpoints on the Ingress, as I mentioned previously in the video, because running websites unsecured on port 80 in this day and age is just not okay. Let's Encrypt exists. It gives you free certificates. You don't need to pay for them anymore. Just use it, make use of it. don't run websites unsecured. So we're going to do that in the next video. I was going to do troubleshooting workloads, but we'll quickly slot this in because it's important. And we will also set up external DNS for creating domains in Cloudflare for us, basically, or whatever you're using. I'm using Cloudflare. And yeah, so Cert Manager will do the certificates for us. External DNS will do the domain setting up for us, so we don't have to do any of that anymore. And that'll be it. So I'll see you in the next video.